Hi, this is Craig with Games with Authentic Battle Damage. I know I promised that today we are going to jump into Unity, and I realized there's something we need to talk about before we do that, and that is inheritance. So I looked for an opportunity in the code where we could implement inheritance, because once we jump into Unity, we're going to get smacked with inheritance right away. And it's going to be something that we're going to have to understand. So inheritance relates to classes. It allows us to take an already established class and build on top of that class without having to interfere with the class itself. So we're going to talk about that. But before we do, let me just come over here and show you. These are all the topics I'm going to want to talk about in Unity. I've started listing out all of the interesting things, and there's so many cool things. So as part of this whole series, my goal is, besides wanting to show you that you can do this, like I don't care if you're 10 or if you're 60. The thing is, you can learn all this stuff, and I really wanted to separate what is part of the C# programming language and what is part of Unity. Because what you really need to do is you need to be able to separate those two, because Unity leverages the C# programming language. And it's important that we keep these concepts separated so that when you're thinking about how to do something or where to do it, you understand the differences. So, okay, let me just also give you a little teaser. This is the rock, paper, scissors mock-up I started creating. As you can see, I've already started building out what our rock, paper, scissors game is going to look like. And basically what I'm going to have do is when the game starts, down here it'll tell you to choose. So you get to hit one of these buttons. And then from here, your choice will come. But before that happens, there's going to be a light right here. So it's going to be a green and red light. Green meaning that the computer player's chosen, and red meaning hasn't chosen yet. So once it chooses, then you can choose, and they'll both drop down together. And I've created these animations so that you can see. In fact, let me just show you this quick. Whoops. Let me bring all these guys in. So these are going to be the guys that are falling down, and they're going to come just like this. They're going to go drop, bounce, and then like for example the rock may be over here, bounce, and then let me run this, and let me select the rock, and so let me just show you what rock pounce looks like. So I created this little animation. So it's going to go jump in the air and pounce, and then hit the other thing. And then let's show you the scissors. It's going to be cutting the paper up, and then the paper. The paper is going to float and then cover the rock. So I'm going to show you how I did all of this stuff. It's fun. And then this is the program I used to create it all. The pixel art, it's called Pixel Edit. So, yeah. All right. Let's go ahead and stop this, and let's get into our inheritance. All right. So I was looking for an opportunity. Where can we implement inheritance in here? And if you guys can think of another place based on my explanation, let me know. But one of my thoughts was, let's right here in the player class, we have choose weapon, and if it's a computer opponent, we run this functionality, and if it's a player opponent, we run this functionality. So why not use inheritance to split out this functionality into two separate classes? We'll create a player class and a computer class, and then we'll have a base player class that they'll both inherit from. So all of this functionality in here is basically what the base player class would be. So let's go ahead right away and refactor this. And we're going to call it base player. And all of this should work. See if we get any errors. Nope. So yeah, everything should be fine. Oops, too many characters. So that's good. So then what we can do then is we create a new file, and we will call it player. Now, that was interesting. Now let me show you something here. Here's the constructor, right? Now, whenever a new class is created, and that goes for every single one we have here, there's something that you're not seeing. Every class inherits from object. Let me show you how this looks. Let's go into our view. Let's go to a console. Let's right click. Oops. Go to declaration. And when we go to the declaration of the console class, we can look at its base type, and we see that it's object. So every class in C# inherits from object, and it looks just like this. You put a colon and then the class that it inherits from. Now, even though this isn't written, implicitly it's there. So what we're going to do is we don't want this to inherit from object. We want this to inherit from base player. Now, base player inherits from object. So basically what we've got is player inherits from base player, which inherits from object. So that's what's going on here, because everything inherits from something. And this inheritance allows player to have access to stuff in base player. Now, because I added this inheritance, I'm going to compile it, and I want to show you what kind of errors we're going to get. The first error that we get is that base player does not contain a constructor that takes 0 arguments. What it's saying is that our constructor here has 0 arguments for its constructor, and base player doesn't have that. Now, let's go to base player's constructor. Here it is. Now, if we added a new constructor for base player and we gave it this, and then we came back here and we compiled, no complaints, right? Let's go ahead and comment this out. Let's do it again. Now it complains. See, the base class has to have a matching argument for this. Now, we don't want there to be a 0 argument constructor, because we have some important information that comes through the constructor, like name. So let's go ahead and fix this. So if we do string name and then bool computer opponent equals false, and then when we compile it, we see we still get an error. It's still saying that the base player does not contain a constructor that takes 0 arguments. And the reason, what we need to do here is we need to basically say, hey, we need to call from this function, we need to call base name computer opponent. There. Oh, I spelled it wrong. Opponent. Okay, there. So what's happening here is we're extending this constructor, and we're saying, hey, we're going to call the base name computer opponent. And if we didn't put these here, they wouldn't be here for us to pass them in. Let me show you how that works. See, now it's saying, hey, well, I don't know what you're talking about, name and computer opponent. Those guys don't exist. So if to think about this, basically what's happening is it's like we're coming in here and then we're calling base name computer opponent. So, but we added here at the end so that we, the first thing that happens is the base will get called. And then once this is done, so this will get called first. And then once this is done, then we can write our own code here if we want. But we don't have to. So now let's go ahead and create our second class that's going to inherit from base player. And we're going to want to do the same thing. String name, bool computer opponent equals false. And base, base. Oh, duh. So funny. I started typing this, and so watch what happened. And I was like, whoa, wait a second. Where's our arguments? Why is it not there? Oh, because we haven't inherited from base player. That's why. There we go. Name computer opponent. Okay, there. Great. Now, what we want to do is we want to take this chosen weapon or choose weapon, and we want to take the functionality and we want to put them into each of these classes. So what we'll do is we will, I'm going to purposely create some errors here because I want you to see them to understand how inheritance works. Okay, so public void choose weapon. There. And then we'll take our player stuff here and we'll put it in here. And then let's do the same thing in computer opponent. We'll deal with that red here in a second. Void choose weapon. Right, and we'll take our computer opponent specific logic and we'll put that here. All right, now I told you the reason why inheritance is great is because we can access stuff from the base player in here. Now, chosen weapon is part of base player. So why in the heck is it red? Why can't we access it? Let me show you. This goes back to our discussion about access modifiers. And a lot of access modifiers are used in determining what classes that derive from other classes have access to. So let's go take a look at chosen weapon in base player, and we see that it's private. Private is only accessible to the base player class. If we want to make this accessible to our derived class, one way we can do it is we can make it public, but we don't want that. We purposely did this because we don't want people to alter this variable directly, because we want to have a getter and no setter. So what we can do is we can use a different access modifier called protected. And now if we come back to computer player, you'll see chosen weapon is available. So this way, let's take a look at, let's try something here. Right here. Dot underscore is computer opponent is available. Oh, you know, I noticed this in a previous video that I'd mistakenly made that public. Look what I did. I did a public here and a public here, when really what I wanted to do was private. Anyway. But anyway, my point was here was to show you that, see, we can't access chosen weapon. But now the computer player and the player can. So also the random object is private. So we want to make that protected. The 4 access modifiers are protected, public, private, internal. Those are basically the ones that I use all the time. So, all right, great. So all of this code in here is accessible to the player, you know, as long as it has the right access modifier. And this is another really cool thing. We can constrain what the player has based on to the base player. So that's cool. Now, because we made rand protected, now it's getting used here. So this is great. So this is exactly what we want so far. Now in here, we don't want this to get called. So let's just put in some right lines to see what's getting called. Base call, and then here player call. This would be like our debug statements, and computer call. All right, so let's. All right, okay. Remember, I told you I wanted to purposely get some errors, and that's what we've done here. It's saying now that our choose weapon hides inherited chosen weapon, choose weapon. So what it's saying here is because we defined this, now this is just a warning. This is going to get called instead of this. Now that's what we want. But I don't like warnings. I mean, I don't want to have a warning. So what we need to do is in the base player, we need to specifically say, hey, you know what? We want classes to be able to override this. And this is such a great warning because think about it. Like maybe we didn't want this to be overridden. So what we can do is in this base player class, we can say, well, let's make this, we can add a new modifier. We'll make it public virtual. And that is telling other classes that, yeah, go ahead and override this. And then here, what we can do then is we can literally say override. So we're making it explicit that we are overriding a function in the base player class. And again, this is so important because when you're writing code, like let's say, for example, I misspell it and I do public override void choose weapon. Oops, why did I do that? Choose weapon. Okay, and then if I try to compile this, it says is marked as override, but no suitable method found to override. And then I'm like, what are you talking about? And then I go, oh yeah, because I spelled it wrong. Okay, so these are protections to help you not make mistakes that cause you bugs and you spend hours trying to figure out where the heck it came from. All right, so in the computer class, we can do the same thing, override. Okay, let's run this. All right, now let's go ahead and run this. Base call, it's a draw. Would you like to play again? This is totally messed up. Look at this, it's awesome. I love it. All right, that's because I don't think we've implemented this properly at all. So Now, when we add a new player, we've now changed it so that it's not being done with this variable anymore, the computer opponent, right? So we're using a concept called polymorphism. So depending upon what kind of class it is, that's what chosen weapon gets called. So let's go over to our model, add new player, player name. Here is where we need to now check for, is it a computer opponent? So if computer opponent, we want to make, here we'll do this, we'll do base player equals null, okay? And then here, if it's a computer opponent, we're going to do player equals new computer player. Now, we have to add in the player name. Now, because we're doing the computer opponent check here, we don't need to pass in computer opponent anymore. So we can actually remove this from our constructor. Because really it's not needed anymore, because if we create a computer class, we know, or a computer player class, we know that that is a computer opponent. And we're using polymorphism to call the right thing. So, all right, is computer opponent, and then we can just get rid of that, and we don't need any of this code anymore. There's nothing better than deleting code. I'm going to go ahead and run it and make sure we get an error so it can point to me. Okay, yeah, so we don't need this anymore. But we don't want to do a new base player. We want to do player. Okay, so else player equals new player name. There. Okay, so if it's a computer opponent, we'll create a computer opponent. And now because base player is the base class, we can do this. We're passing in a computer player to a base class because it inherits from it. So this allows us to take two different objects and treat them like they're the same. It really simplifies things, and I like it. So okay, now the big thing that's going to happen is when, right in here where we do choose weapon. See here we've got the computer player and the live player. When on the computer player, when choose weapon is called, this code's going to get called. And when the player does choose weapon, this code's going to get called. So now we've moved this class-specific code into specific classes. So let's go ahead and run this and see what result we get. All right. Now here, see where we got computer call? Now we're going to choose our weapon, and we should get player call. Isn't that cool? So it's holding, let's just take a moment to understand what just happened, because this is really cool. In our model, we have a list right here of base players, okay? And when in here, when we get that specific player and we call choose weapon, it's calling code that is, typically would be on here, choose weapon, but it's being called in these specific classes. So this allows us to based on the type of class and using polymorphism, we can, call two different lines of code, which is really cool. Now, let me show you another problem. Base player, there should never really be a base player. So if, like, for example, if someone said, base player B equals new base player, and if we called B dot choose weapon, let's go ahead and run this. Oh, oops. Got to give it a name. Base name. Okay. Let's run this. And we'll see, let's see here. Oh, oops. We're not seeing it because everything's getting wiped away by the clear. So let's do it right here, because I want you to see what happens. Okay, base call. Well, let's look at base call. It does nothing. It doesn't even choose a weapon. So that would create an error. So we don't really want anybody to create a base player. So how do we restrict people from creating a base player? Well, the way we can do that is we can make this class abstract. So public abstract class. Then we can go down here too, because we don't really need any code in here. So to make, we can make this method abstract as well. And when you make an abstract method, you never give it curly brackets. So let's do that. Abstract. There. So basically what this is saying is, you know, we don't want anyone to create a base player, and we want them to override this. So let's go ahead and run this, and we should get an error. Cannot create an instance of an abstract class or interface. Perfect. But once you override it, you can create classes that have been overridden. Okay, so I want to show you one more thing. What happens if we create a base class here, but we don't override chosen weapon? Player does not implement inherited abstract member base player.choose weapon. This is one of the cool things about abstract classes. If you make an abstract method, it forces the programmer to inherit that, because it's part of the contract of the class. The class is saying, hey, this is an important method, and we're not going to put any functionality into it. You have to implement it on your own. And so because we didn't implement it, that creates an error. So does not implement inherited abstract member. So there. That is inheritance. There's a lot of it in Unity, and we're going to go over that once we get there. So thanks guys for watching.